In this example, we have 2 over r minus 3 plus 4r over 5. So in this example, we have a rational expression, or an expression, r minus 3 in the denominator. So when you have an expression, it's always best to check if you can factor. There's nothing in common between r and negative 3, so this expression is in its simplest form, so we don't have to worry about factoring. Now, next is to identify the LCD. So let's identify our LCD. Now, according to the denominators of the two fractions, this fraction has r minus 3, while the second fraction has a 5. So its final form of the LCD for this, meaning that in our final answer you should write 5 first, and then r minus 3 in parentheses. So this will be the final form, meaning this is the denominator in the final answer. And then we're going to use what I wrote the first time to compare the LCD with each respective denominators. Alright, so let's take a look at the first fraction. The denominator, r minus 3, it has that. And if I compare it with LCD, the only thing that's missing is a 5. So I'm going to multiply the numerator and denominator by 5. So let me put the parenthesis on the r minus 3 and the 2. Now, I'm going to compare the second fraction and its denominator with the LCD. It has a 5 but missing the r minus 3. So I'm going to multiply the numerator and denominator by r minus 3. In addition, I'm going to include parentheses on the 5 and the 4r. With parentheses, that way we can visually see that, alright, I'm going to multiply by distributing the 4r to the r and the minus 3. Now, since both of the fractions will have 5 and r minus 3, that means that we can combine the numerator together. So I'm going to rewrite it as one big fraction. It's going to be 5 times 2 plus 4r times r minus 3 over my LCD, so r minus 3 times 5. Next, we are going to multiply in the numerator that you can see. So I'm going to multiply the 5 with the 2, and then here the 4r I'm going to distribute to the expression the r and the minus 3. So in the first part, 5 times 2 is 10. Then I'm going to bring the plus. Next is 4r times r. That's going to be 4r squared. I'm going to include my parenthesis. And then 4r minus 3 will be negative 12r, close parenthesis, over our LCD. Now, again, good practice in the event when we're working with subtraction. I'm going to distribute my plus to the 4r squared and the negative 12r. So when I distribute, this is what I'm going to have. I'm still going to have the 10 in the front. Positive times 4r squared will be positive 4r squared. Positive times negative 12r will be negative 12r over r minus 3 times 5. Alright, now let's check if there's any like terms that we can combine. I have a 10 regular number, I have the 4r squared and negative 12r. Now these two I cannot combine because this is an r squared and this is just r. They have different exponent. In order to combine, they need to have same exponent. And I cannot combine with a 10 because it's just a number without the variable. So I'm going to rewrite my final answer. I'm going to put the numerator in order. So I'm going to write with starting with the highest exponent. So 4 r squared, and then minus 12r, and then since this is a positive 10, I'm going to write plus 10 over my LCD, which is 5 times r minus 3. And then I'm going to box my final answer. So, when you cannot combine like terms, simply just put your numerator in order, just like this. And then, if you have a single number multiplying to an expression, we put the single number in the front and our final answer. And that's all you gotta do.